welcome back. In this video, we would be discussing about behavior of seismic waves and how the behavior of seismic waves justifies the nature of our interior, that which layers are solid, which layers are liquid. Let's start. So, what are seismic waves first of all? Seismic waves. Seismic waves are actually the energy waves. Seismic waves are actually the energy waves, and this energy would travel through Earth's interior, and this energy would be generated whenever we have an earthquake, or to some extent we have an explosion. So if we have an earthquake, if we have an explosion, as a result of that, energy would travel, and that is being known as what? Seismic energy. Energy is always propagate, or energy is always depict in terms of waves, so we used to give a name as seismic waves. So here you can see that we have a seismic waves. Suppose explosion is taking place here on the surface, so we would have a energy which would going to travel in all direction, and this energy which is traveling in all direction, that is being given a name of seismic waves. Similarly, if in the interior part of our earth, whenever we have a explosion or we have an earthquake, as a result of that, energy would travel in all direction, and the name which is given to this energy is basically the seismic energy. Energy is being depicted in terms of waves, so that is being called as seismic waves. So here we have the seismic waves. We have two types of seismic waves specifically. When the energy is traveling in all the direction, we have a two types of seismic energy. One is P waves and another one is S wave. P wave is basically being known as primary waves, and S wave is known as secondary waves. So whenever there is an explosion, whenever there is an earthquake which is taking place, there will be a energy which is moving in the crust part of our earth. Technically, all earthquake would take place in lithosphere. Okay? All earthquake would take place in lithosphere. So what we can say that when we have an earthquake in lithosphere, the energy will move in all directions. Waves, we can say, energy would radiate off in terms of either P waves or S wave, primary wave or secondary. So this is what a general idea about seismic waves. Now, if we deep dive in this particular seismic waves, so we have a two set of waves. We have a P waves, I told you, S wave, I told you. Now, P wave is basically an example of compressional waves. P wave is an example of what? Compressional waves. It is longitudinal wave. Here you can see in this particular animation that here we have a P, and this is what the direction of energy, and this is what the direction of particle movement. Here what we can say that the direction of energy propagation and particle movement will be in forward and backward direction, in back and fro, we can say. So particles, here you can see these slabs are there, so these slabs are either moving in this way or these slabs are moving either in this way, so that is being called as back and or forward and backward, you can say. So in the P waves we have what? Forward and backward kind of movement. So whenever the earthquake is taking place, during that point of time, what would happen? P wave would going to release, or P wave would going to propagate in terms of seismic energy, and that energy would going to change the rock slabs which are there in our earth crust part, and that change would take place in this, that the energy will propagate in this way, and rock will going to adjust while moving forward or backward. Okay, so this is what the P wave which used to propagate in our Earth's interior. Now these P waves are same as that of sound waves. They are same as that of sound waves, means they have a tendency to bend, they have a tendency to refract. If there is a change in the medium, so these P waves would going to refract. Their speed would also going to change when the density is changing. These P waves have a push and pull kind of motion. Here you can push and pull kind of motion parallel to wave direction. These are the fastest seismic waves. These waves are fastest. P waves are the fastest because when there is a release of energy, so because there we have a back and flow kind of wind, so as a result of this, it will going to appear first on the surface. For example, let's say here we have a like a P wave, and this is how the S wave would going to move. So it will take a time in order to make that particular you can say the cycle. So this will take fast to arrive on surface. So that's why P wave is fastest seismic waves. And yes, one of the most contrasting feature which you have to remember, which you have to focus upon, you should pay attention that this P wave can travel through all mediums, solid, liquid and gases. It can travel all mediums, solid, liquid. Moving ahead, now let's see the feature of S wave. S waves are example of shear or transverse waves. They are analogous, means have a similar characteristics as that of light wave. Okay, have a similar characteristics as that of light, means similarly they can also bend, and their angle of a path would also going to change if there is a change in density, and they would show a side to side up and down motion. Here you can see we have what? Up and down. We have up and down kind of motion. So this is basically being known as up and down kind of motion with respect to these P waves. So when we have a up and down kind of motion, that will be termed as what? S wave. And here the propagation of energy is in this way, but the movement of particles is taking place basically with respect to the perpendicular ways. Here the energy as well as the particle motion is parallel. Here the energy and the particle motion is perpendicular to the wave direction. Here we have a perpendicular motion. This one is slower than P waves because its wavelength is greater, so it will take a time in order to complete a one cycle. And this S wave arrive on surface after the P waves. And one of the most contrasting feature, S stands for solid only. So this S wave can only pass through solids. Can only pass through solids. P wave can pass through all mediums. S wave can pass through only solids. Just remember S for solid.